Continuing with the sine law, we're now going to look at the ambiguous case of the sine law.
So we have this triangle where one side is unfinished. This is angle A here, so the side that's not drawn would be side A. This is side B, so the angle that connects with this line here will be angle B, which leaves us to believe that up here we would have angle C, and then this would be side C. And we don't know the length of side C. The picture is just drawn to go all the way across, but might not actually be that long. So let's first calculate the height of the triangle. So if this triangle was a right triangle, let's calculate the height. To calculate the height, we can use our basic trig ratios from SOHCAHTOA because we now have a right triangle. So we have an angle A, we want to find H, which is the opposite, and we have the hypotenuse. Then we would use sine. Sine theta equals opposite over hypotenuse. In this case, sine 30 degrees equals, our opposite is h, our hypotenuse is 10. Put a 1 under the trig function, and then we can cross multiply and divide. Let's make sure we're in degree mode first. Do sine 90 equals 1, so we're in degree mode. Okay, sine 30, move out of the brackets, times 10, and dividing by 1 wouldn't do anything, so we get 5. H equals 5, and units would be centimeters. Okay, next, if A equals 6 centimeters, so the side that is not drawn, if that was to equal 6 centimeters, how many triangles would you get? Sketch the results. Now, I can't put a ruler on the iPad and measure, but you can put a ruler on your paper and measure. So I'm just going to go based on my notes. So if we took a ruler and we put 0 at the point where C is, and then we measured straight down, 6 centimeters would be hanging down here. So that's not going to work because it needs to meet up with side C. If we swung it so that 0 is here and the ruler went this way until when the 6 centimeter mark meets up with the bottom line, then that creates a triangle. So let's say that it's approximately here. But then we can also swing our ruler the other direction. If we swing our ruler this way and make sure that the 0's on the capital C and then the 6 measurement lines up with line C, then we see that we can also have a triangle where side A is leaning this direction. So that might look something like this. And these are 6 centimeters, 6 centimeters. So if A equals 6 centimeters, how many triangles would you get? We get 2 triangles. Let's just write a note of what we did. Use a ruler to measure 6 centimeters between angle C and side C. And our results, one triangle that looks something like this. We have 30 degrees here, 10 centimeters for B here. We don't know angle C, we don't know angle B, but we know side A is 6 centimeters. Or the other triangle that we got looks something like this. We still have 30 degrees for angle A. We don't know angle C. We don't know angle B. Side B is 10 centimeters. Side A is still 6 centimeters. And we don't know side C. So in this situation, we get two triangles. When A equals 6 centimeters. The next situation, if A equals 12 centimeters, how many triangles would you get? Sketch the results. So if A equals 12 centimeters, do the same thing. Put your ruler, put 0 of your ruler at angle C, and then measure your ruler and swing it around until you can match up 12 with the bottom line. So here, if I put it this way, it's going to go off. You're not going to be able to match it up. It's just too big. Same with going down. It's going to go way off. The only way that you can get it to line up is if you go this way, and it's going to look something like this. Okay, it's going to line up with almost the end of that line. So something like this. And that's A equals 12 centimeters. So how many triangles do we get from that? We only get one triangle, and it looks something like this. Angle A is always 30 degrees in this particular example. We don't know angle C, we don't know angle B. Side B is 10 centimeters. Side A is what's changing. This time it's 12 centimeters, and we don't know side C. We get one triangle when A equals 12 centimeters. And then the last one, if A equals 2 centimeters, how many triangles would you get? Sketch the results. So if A is equal to 2 centimeters, 2 centimeters is pretty short. So it might only go to here. And if I go this way, it only goes to here. If I go this way, it only goes to here. If I go this way, it only goes to here. So do I ever get a triangle? No, because it's too short to ever meet up with side C. What we get looks something like this. This is not a triangle. We still have angle A is 30 degrees. We don't know angle C. We don't know angle B. Not that there even is an angle in this case. Side B is 10 centimeters, and then side A in this case is 2 centimeters. When A equals 2 centimeters, we don't get a triangle. An ambiguous case occurs when we are given angle side to side in a triangle. The angle must be opposite the given side. Given angle A, side B, and side A, if angle A is acute, we have three possible scenarios. The first scenario is that side A is greater than side B, and here we can have only one obtuse triangle. We saw this when A equaled 12 centimeters on the previous page. An example angle A, side A. We always want to put the angle we know when we're drawing a triangle. We're not sure if it's going to be ambiguous case. Put the angle you're given in the bottom left corner. The other side that we know, which in this case we'll say B equals 8 centimeters, you want to put it here in the diagram, so on the left side. And then this would be our other angle, you can call it C, and side C. So if A is bigger than B, let's say A equals maybe 11 centimeters, then we get exactly one triangle. It's going to be an obtuse triangle because this angle here will be bigger than 90 degrees. The second scenario is when A equals to H. That gives us exactly one triangle, and it's going to be a right triangle. Note, if A is less than H, we can't make a triangle. We saw this when A equaled 2 centimeters on the previous page. An example. We'll use the same values for angle A, 35 degrees, and side B, 8 centimeters. Side A would equal H, the height of the triangle. Then we have angle B is 90 degrees. Side C, we don't know. So if side A, which is the side across from the angle you know, is equal to the height of the triangle, angle triangle. We can calculate H, and you're going to need to know it for the next one. If your A value is smaller than your B value, then you're either in scenario 2 or 3, so you need to calculate the height of the triangle to check if your A value is greater than the height. The A side is opposite, and then our B side is our hypotenuse. When we're calculating the height, we're using a right triangle, so we can use SOHCAHTOA. We're going to use sine theta equals opposite hypotenuse. Then plug in our values. Sine of 35 in this case equals H over 8. Put a 1 underneath, cross multiply and divide. Sine 35, move out of the brackets, times 8, and then divided by 1 won't do anything, so 4.5886. And in this case, that's the A value, so we'll round it to 4.6 centimeters. So if your A value is equal to the height of the triangle, then you get one. The third scenario is if your A value is greater than the height of the triangle, less than side B. In that scenario, we can have two possible triangles, which makes this case ambiguous. We saw this when A was equal to 6 on the previous page. Using our same measurements, we have angle A is 35 degrees. Side B is 8 centimeters. Side A would have to be bigger than 4.6 because we just calculated that for this triangle that was the height. So it'd have to be bigger than that, but smaller than 8. So maybe it's 5 or 6 or 7 or somewhere in between. So I'm going to go with this example. We'll say that A was 7 centimeters. And then we have angle C and side C and angle B. So this is with side A swung to the right side, but we saw in our example on the previous page when A was equal to 6 that we could also swing side A to the left side and we could have it match up. So that's where we get two different triangles. So I'm just going to draw a little dotted line in here. And you should notice that these two sides are equal. Obviously, they're both A. So that would mean that it's an isosceles triangle, which also means that these two here are equal. Angle A is still 35 degrees. Side B is still 8 centimeters. Side A is still 7 centimeters. We don't know angle C, we don't know side C, and we don't know angle B. And we could draw the dotted line for what it looked like when side A was swung to the right. So look like that. And again, that would be an isosceles triangle because our A value doesn't change. So whether the side A is swung to the left or to the right, it's still 7 centimeters, which means that these be the same. Given angle A, side B, and side A, if angle A is obtuse, then there's only one possible triangle. If the given angle is obtuse, which means greater than 90 degrees, this cannot be the ambiguous case. Therefore, there is only one possible triangle. So an example, let's say that now A is 120 degrees. So the triangle looks something like this. Side B we could still say is 8 centimeters. Angle C we don't know, side C we don't know, angle B we don't know, and side A is, it would have to be bigger than side B, and let's say side A is 14 centimeters. So we get only one possible. Summary. The ambiguous case of the sine law may occur when you are given two sides and an angle opposite one of the sides. So you have side, side, angle. For ambiguous case in triangle ABC, when angle A is an acute angle, if A is greater than or equal to B, then we have one solution. If A is equal to H, the height of the triangle, we have one solution, and it's going to be a right triangle. If A is less than H, we will have no solution, and if A is greater than H but less than B, we will have two solutions. That's our ambiguous case. And we need to solve for both possibilities. So let's put this into action. We have triangle ABC, angle A is 39 degrees, side A is 6 centimeters, and side B is 8 centimeters. What is angle B, angle C to the nearest degree? I'm given an acute angle and a side A that's opposite my acute angle, which is less than B. So A is less than B. I could have the ambiguous case. What I need to know next is A greater than H? If A is greater than H, since A is less than B, then we would have the ambiguous case and possible solutions. So let's figure out what the H value of this triangle. Draw a right triangle. Doesn't really matter what it looks like. Draw a right triangle. Put your angle that is known in the bottom left, whichever letter it is. Doesn't matter if it's called A or if it's called C or if it's called S, whatever. Put the angle you're given in the bottom degrees. This angle would be, and it's 90 degrees. Side is 8 centimeters. We want to put our other side next to left. Then we have angle C at the top, side C at the bottom, and then we're calculating the height of our triangle to see if it's bigger than that. Using SOHCAHTOA, the height would be opposite our angle, and side B is our hypotenuse. Then we're using the sine ratio, sine theta equals opposite over hypotenuse. Sine of 39 degrees equals h over 8. Put a 1 underneath. Sine 39, move out of the brackets, times 8. 5.0345. H equals 5.0345 dot dot dot. So A, which equals 6, is greater than H. Therefore, H is less than A, which is less than B, and this tells us that we have two possible solutions. Once we've determined that this is the ambiguous case, we do have two solutions. We now need to look at each solution independently. So we break it down into case 1 and case 2. For case 1, you always want to start with the triangle scenario, which is when side A is swung out to the right. So I draw my triangle. Angle A is 39 degrees. Side A is 6 centimeters. Side B is 8 centimeters. Angle B we don't know, angle C we don't know, side C we don't know. The question wants us to find angle B and angle C to the nearest degree. We have a pair, angle A and side A, and we also have half of a pair. We have side B. Sine law to find angle B. Sine A over A equals sine B over B is our sine law. Sub in the information. I'm going to put sine angle B first. I just like to do the unknown first. And then over side B is 8 equals sine of angle A, which is 39 degrees, over side A, which is 6 centimeters. Then we cross multiply and divide. Divide by your third. Sine 39, move out of my brackets, times 8 divided by 6 gives me 0.8390. Sine B equals 0.8390 dot dot dot, which means B equals sine inverse of 0.8390 dot dot dot. So I go second function sine, second function negative button to put the answer, and then enter to get 57.04. Rounded to the nearest whole number, B equals 57 degrees. Next, I want to find angle C. I know that the three angles in any triangle add to 180, so angle C would have to equal 180 degrees minus angle A, 39 degrees, minus angle B, 57 degrees. 180 minus 39 minus 57 gives me 84. So angle C equals 84 degrees. So we've solved case 1. Next, we need to do case 2. This is when our side that's opposite from our given angle is swung in to the left and we get an obtuse triangle. Something like this. Angle A is still 39 degrees. Side A is 6 centimeters. Side B is 8 centimeters. We have angle C, side C, angle B. We can draw what it looked like when we had side A swung out to the right. And this portion here, this creates an isosceles triangle. The two sides are equal to 6 because they're both A, which means these two angles are equal. So why we always have to do the acute triangle situation first. We know that this was 57 degrees. Angle B was 57 degrees. That also means that this angle is 57 degrees. Then, how do we find this angle here, which is B of the obtuse triangle? We know that a straight line is 180, so from here to here, all the way along the bottom, that angle would, and we know that this portion is 57, so that means that this portion would have to be 180 minus 57. B equals 180 degrees minus 57 degrees. 180 minus 57 is 123. So B equals 123 degrees. And then find angle C the same way we found it in case 1. The three angles add to 180. So angle C must equal 180, subtract angle A, which is 39, subtract angle B, which in this case is 123 degrees. 180 minus 39 minus 123 gives us 18 degrees. Angle C is 18 degrees. So to recap, if you're given a question that could be the ambiguous case, so you're given one angle that's acute, you're given the side across from that angle, and you're given another side. First you want to check, is the side across from your angle smaller than the other side? If that's a yes, then it could be the ambiguous case, but you need to know if the side across from your angle is greater than the height of the triangle. So you draw a right triangle and use the sine ratio to calculate the height, and then you compare that to the side that's across from the angle, and you just greater than the height or not. If it is greater than the height, you also had that it was less than the other side, so now you have the ambiguous case. Then you have to solve by doing case 1, which is always the acute triangle first, so swinging your side opposite your angle out to the right. You solve that using the sine law and the property that the three angles in a triangle add to 180. We could also solve for side C if we were asked for that. In this question, it didn't ask us for that, but we could use the sine law once we know angle C to find side C. If you are using the sine law to find side C, then don't use the rounded value of angle C. keep some decimal points to make your side C more accurate. Next, we have to do case number 2. Case number 2 is the obtuse triangle, which is when we swing the side opposite the angle given to the left. We do this 1 second because we use the information from case 1. So we get an isosceles triangle, which means that the two sides are equal, of course, because they're both A, but also that the two angles are equal. So we know that those two angles equal whatever we got from case 1, which in this case was 57. Then we use that to find that angle in this case by doing 180 minus whatever our angle was from case 1. And then we find our third angle the same way we did in case 1 by using the property that the three angles in any triangle add to 180. And again, you could solve for the missing side length, but if you're doing that, make sure you don't just use 18. Use a more accurate angle, so keep like 4 numbers after the decimal to calculate. And just use your sine law with side A, angle A, and then angle C, and find side C. Hints. How do you know if a question on a quiz or a test is ambiguous case? Well, it took a lot of space. So if you have a question like this, where you're not given a picture, but you're told an angle, the side across from that angle, and another side, and then you have a lot of space to write your answer, it's a good hint that it's probably ambiguous case. Also, if the question's out of a lot of marks, sine law is not really that hard, so it might be out of like 1 or 2 marks. If your question is out of a bunch of marks, maybe like 6, that it's going to be ambiguous case.